Good morning and welcome to our lesson today. Today we are going to study lesson 7.9, geometric sequences as exponential functions. The first thing we need to remember is let's take a walk back to first semester when we talked about an arithmetic sequence. An arithmetic sequence is a sequence in which we are adding or subtracting the same number to each term. So something like 1, 2, 3, 4 is an arithmetic sequence, and I know you can all find the next three terms. It would be 5, 6, and 7. Today we are talking about a geometric sequence. A geometric sequence. A geometric sequence is a sequence in which each term after the first term is found by multiplying the previous term by a number that is not 0, obviously, and that number, r, is called the common ratio. How do you find the common ratio? If you can't see it right off the bat what's happening or what the progression is in your sequence, you would divide the second term by the first. You would divide the third term by the second. You would divide the fourth term by the third, and they are consistent, then it is a geometric sequence. So we have three choices. Is it an arithmetic sequence because we're adding or subtracting? Is it a geometric sequence because we are multiplying by the same constant? You could multiply by a fraction, or you could multiply by an integer, or is it neither? So let's look at our first example here. Our first example, determine whether the sequence is arithmetic, geometric, or neither. 21, 63, 189, and 567. Feel free to use your calculators if you need to. That one's pretty straightforward. When you have an answer, raise your hand. And right here in the front, what'd you get? So what kind of a sequence is it? It's a geometric sequence. What's the common ratio? Good. We are multiplying each term by 3. Anybody have a question? Are you sure? Okay, let's take a look at an example down here. How about number 1? Number 1. Determine whether each sequence is an arithmetic, geometric, or neither. So we have 1, 2, 4, and 8. 1, 2, 4, and 8. Yes?
It's a geometric sequence and explained by 2.
It's a geometric sequence and we're multiplying by 2. How about number 4? Let's look at number 4. So number 1 was geometric, and r was equal to 2. Number 4, what are we doing? Anybody? Joseph? We're adding 7. So what kind of a sequence is it then, Joseph? An arithmetic sequence. Does anybody have a question? Hello? Today's a relatively simple lesson. Okay. Okay. The next thing that we would like to do is we want to find the next three terms in a sequence. So let's just look down here. We want to find the next three terms in a sequence. So we have 648, negative 216, 72. We should be smart enough to figure out that my next answer has to be negative, yes? So let's see what we've got going on here. Do you have the answers in your notes?
No.
No. Okay. Not for this one. Okay. you have the answer? Yeah. Who's got it? Yes.
I got negative 24, 8, and negative 2.7.
Let's see. I think you're multiplying by negative 1/3, correct? So let's just double check that last one. This is actually, you've rounded here, so that I would not prefer. So the correct answer that I would prefer there would be negative 2 2/3. Are you with me?
Mm-hmm.
Okay. Anybody have a question? So I think we're all confident in doing those simple tasks, yes? Determining if it's a geometric sequence, an arithmetic sequence, and extending a sequence. Yes, question?
Could you just explain what an arithmetic sequence is?
Yes, an arithmetic sequence is like the one I did at the very beginning of class. An arithmetic sequence would look like this, when you are adding or subtracting the same number. So, x plus 1, x plus 2, x plus 3. Your next term would be what? X plus 4, x plus 5, x plus 6. 4, 2, 4, 6, 8. And you could fill that in. That's an arithmetic sequence. Yes?
So anytime it's like a decimal, you don't want us to round, you want us to make it a
Don't round. It's not an exact answer. When you round, you just changed it. Yes, John, that's fine. Any other questions before I move on? All right, here we go. To find the nth term, a subscript n, of a geometric sequence where the first term is a subscript 1, the common ratio is r, we are going to use this formula. The nth term is equal to the first term times r to the power of n minus 1. To the power of n minus 1. So let's just go ahead and make sure we have that formula. That's to find the nth term of a geometric sequence. And I'm going to find it with you right now so that you can see how it's done. So let's go in our notes. So we should be on our second page there, the second page of our notes. And I'll do a problem with you. All right, so let's look at the example that they've given us, and we'll work one together. And then I have one concept to teach after this, which would be finding the geometric means. Finding the geometric means. So we want to write an equation for the nth term. And here's my sequence. 5, 20, 80, 320. The first thing I want to see is the formula. The nth term is equal to the first term times r, the common ratio, to the power of n minus 1. So let's find out what we have here. What's my first term, or a subscript 1, class? 5. What's my common ratio? What am I multiplying each term by to get the next term? 4. And this is the part you guys don't like, because when it's general and specific, listen to what I'm saying. When it just says write an equation for the nth term, you just let n stay n. Are you with me? I didn't ask you to find the 7th term or the 10th term. So now your equation would look like this. The nth term is equal to 5 times 4 to the power of n minus 1. That's the equation to find the nth term. Are you with me? Yes? Part B says, find the 7th term. I'm going to change it. So let's find the 15th term. Let's find the 15th term of the above sequence. So for those of you that want to sit there and keep multiplying everything by 4, this is a shortcut, because if they asked you to find the 200th term in the sequence, obviously you're not going to sit there all day. So now what you want to do is realize that n is equal to 7, and we're using the equation from above. Do you all understand that? Do you understand why? It's the same pattern. You've already given me a generic formula with n left in it. Now I'm being specific and asking you to find a specific number. We're going to find the 15th term. So give me a minute to change that. Yes, question? Are you sure? Okay. All right. So here we go. The nth term is equal to, I'm going to just write it again. So the 15th term is equal to the first term, 5, times r, which is 4, to the power of 15 minus 1. Please make sure you do order of operations, because if you guys do 5 times 4, which is 20, and take that to the 14th power, you're not going to get the right answer. Correct? So you have to take 4 to the 14th power. Everybody get your calculators out. You might want to clear those memories. Yep, that's what it is. And multiply that times 5. And this is what I got. 1, 3, 4, 2, 1, 7, 7, 2, 8, 0. Are you with me? So, one more time. Since you stepped out of the room for a minute, let me just review. To write an equation for the nth term of a given sequence, we are using the equation, the nth term, a subscript n, is equal to a subscript 1, the first term, times r, the common ratio, to the power of n minus 1. Okay? Our sequence was 5, 20, 80, 320, ... To write an equation for the nth term, the thing that you guys don't like is n stays as n. So the nth term is equal to the first term, which is 5, times the common ratio, which is 4, to the power of n minus 1. And then the book went ahead, or our notes went ahead and asked you to find the 7th term, and then I just made our life interesting by taking it to the 15th term. And make sure you use order of operations. Okay? Any questions? Okay, we have one more section to look at, and that's that other sheet that I gave you, your additional notes. Does everybody have those? 7.9 geometric means. Okay, this is important. This is not in your textbook, but it's an important concept. You're going to use it in geometry, and I wanted to make sure that I covered it as well. The definition here. A geometric means is the missing term between two non-consecutive terms in a geometric sequence. The geometric means always has two answers, a positive and a negative. It was the half sheet you were supposed to pick up when you walked in. Okay, to find the geometric means, here are your steps. Divide the third term by the first. Take the plus and minus square root of the result from that and then multiply the first term by that result. Now, it's going to make sense when we do a problem. So let's go ahead. What's the geometric means of 2 blank 18? Well, you have to take this into consideration, guys. Look at me. On both ends, the first term and the third term are both what? Positive or negative? Positive. So, we're not really sure if we're multiplying by a positive number or a negative number. And that's why we always take both of those into consideration. So step number 1 says to do what? Divide the third term by the first. And let me just go on record as saying, in other textbooks, they're going to teach this to you in a much more complicated fashion, and you really don't want to learn all those steps. This is really the easiest way to do it. So step number 1, 18 divided by 2, we all know equals what? 9. Step 2, take the positive and negative square root of 9, which would give me what? Plus and minus 3. And step 3 says multiply the first term times plus and minus 3. So my geometric means here would be plus or minus 6. Does that make sense? Plus or minus 6. Okay, you guys try one. Try this next one. 520. 5 blank 20. So you're finding the geometric means. How many answers are you supposed to have every time? 2. Good. Job.
Plus or minus 2.
Okay, that you didn't finish the problem. So you did step 1 and you did step 2. Now you have to multiply the first term by plus and minus 2, which would give you what?
Oh, plus and minus 10.
Good job. How many people got plus and minus 10? Awesome. Okay, so what I've given you here are some additional problems. You have 2 of those. You can include those in your homework for tonight. Okay? And then I've given you one more, find the nth term. So why don't you guys just go ahead and do these real quickly now, and we won't have to even grade them tomorrow. We'll just go ahead and make sure you all understand. So go ahead and find the geometric means of number 2 and 3, and then find the nth term of that problem right there. Alrighty. This concludes our lesson for today. We hope you guys all have a great evening. Thanks for watching.